Okay guys, I finished another workout. I did a lot of the same things that I normally do in my other workouts, like walk a mile. It's a pretty fast mile though. I typically walk a mile in like 16 minutes. Typically. Depends on my day. But going with that mile, we'll talk about the Krebs cycle and the electron transport chain. And this is part of our bioenergetics, just like the phosphocreatine and the glycolysis that I've already talked about. So it is another way for you to get ATP. However, it is a lot slower in the ATP making process. So this kicks in like 2 minutes like into your exercise. So it takes it a minute. That's why our PCR and glycolysis is so important. So in the last video, I gotta make sure I upload these right, because if not, this will be interesting for you. But in the last video, I talked about glycolysis and what you get out of glycolysis. And if you remember, we get 2 ATP and we get 2 NADHs. Well, that NADH can go 2 ways. It can go to lactate plus hydrogen, which is what makes your muscles sore, or it can go into the Krebs cycle, which is part of our oxidative phosphorylation system. So, and essentially what happens in the Krebs cycle with the 2 NADHs from glycolysis is we make more NADHs. From one pyruvate molecule, you get 3 NADHs. You get 1 FADH and 1 ATP. So the purpose of this is not to make energy, it is to make NADH and FADH. So when you use a whole glucose molecule, you'll get 6 NADHs and you'll get 2 FADHs and 2 ATP. Okay, so that NADH and that FADH, they get used in the electron transport chain, which is the second part of the oxidative phosphorylation. And NADH goes in first, and then into the first pump, and then it goes all the way through the second and the third, and FADH enters in at the second pump, and it goes from the second to the third. And in the first 2 pumps, both NADH and FADH put out 4 hydrogens. So in the first pump, you get 4 hydrogens just from NADH. In the second pump, you get 8 hydrogens, 4 from NADH, 4 from FADH. And then in the third pump, it is our weakest pump, and you get 2 hydrogens from FADH and NADH. So you get 4 hydrogens in total. That hydrogen then goes to the ATP synthase, which is at the end of our electron transport chain. And it takes 4 hydrogens to make 1 ATP molecule. So you take 4 and you get an ATP. Well, oxygen also comes in at the third pump, and it's grabbing electrons and a hydrogen, and it makes metabolic water. But to go with our workout, like when I was walking my mile, as I upped my speed trying to maintain my work rate, I was using Krebs and the oxidative phosphorylation cycle. Also, when you're just sitting, when your work rate is really low, like you're just sitting there or laying in bed, you're burning your fats. Because also, fats can just go into the Krebs cycle. They don't need to go through the glycolysis. They use beta oxidation to get in there and Beta oxidation breaks up the carbon rings to make the acetyl-CoA, which is what you need to do Krebs, and it makes NADH to go into the electron transport chain to get your ATP. So the oxidative phosphorylation is super important for endurance activities like me walking up this mountain right now. I'm using my oxidative phosphorylation because it's more work than just standing, but it's not increasing intensity a whole lot. So I'm using majority of my fats, because also, as discussed, we store more fats in our body because our cells, phospholipid bilayers, they're fats. We are made of fats. We are unlimited stores of fats. As to where our carbs, they gone. You only store 2,000 of them, and then they gone. So, yeah, that was my workout.